Welcome students. After the classification of neural networks based on architecture, let us look at the classification of neural networks based on the training algorithm in this session. So what is this training? As we all know, the human beings are very good in pattern recognition. But for recognizing the pattern, it must be in a position to identify the different objects around me. Say, for example, if I find out the carpet and another table of the same pattern, then I can say there is some difference or there is some similarity between these objects. So once if you recognize the objects, then definitely you can make use of the table for keeping some water bottle or something like that, or make use of carpet for something else. Without recognizing the objects, you will not be able to do anything. And not only recognizing objects, you need to find out whether they are with similar patterns or dissimilar patterns. So how the ANN is going to do? It is going to store the pattern of the data first. So without storing, we will not be able to do anything. So a new data is given, which we call it as training process. In the training process, the new data is stored. So once it is stored, which we call it as training or learning, it will can recognize any objects which falls under the same pattern. Here the second process is called as recollecting or testing, but however in this session we will concentrate on the training process. So how does training takes place? It is a process by which a neural network adapts itself to a stimulus by making proper weight adjustments. So whenever a new input is given, my neural network is adapting itself by adjusting the weights. So the process of modifying the weights is called as training a network. So it will take time. You cannot learn the characteristic features of an object immediately. You need to understand what is the pattern, what is the way in which it is formed. Then you can have a grip of the size or shape of the object. So now I am giving you an example. Is gray, has a trunk, has big ears, has four legs. Can you identify what this object corresponds to? It is actually an elephant. If you have said the answer correctly, then your brain is already trained for this animal, elephant. If not, you will be given some more features or some more inputs. Again, you can try and tell it is an elephant. Now, what is this? Has a tail, has whiskers, has four legs, says meow, chases mice, purrs. It is a cat. So this process of storing the data in your brain is called as training, and there are several types. The neural networks is classified based on supervised algorithm, unsupervised algorithm, and reinforcement algorithm. Let us look at the supervised algorithm first. So here a new data is given along with the name of the object. So it is not directly given. Say, for example, you show an image of a spoon. Along with that, you also give the text that it is a spoon. So such type of data are called as labeled data, where you will have the input and also you will have the target. Target is called as desired response, or it is called as expected output. This is an example for supervised mode of training. You can see a known data input where I'm giving spoon and knife, and also I am giving the name spoon and knife in the form of a text data. So the first square box is input, the second one is target. Now both are given together to the algorithm available inside the computer or the model where it is trained. Now it stores the features of spoon and knife. Whenever I give a spoon again or a knife again, it will be in a position to identify correctly that it is spoon. So past history is needed. Without showing some images of spoon and knife, you will not be able to generate the response or predict whether it is spoon or knife. So how do we do that? In the training process, when you store the data, immediately you are not going to get the answer. You will get some error value. Based on the error value, we are going to adjust or we are going to do the training process. Slowly and gradually, the error value will drop down and you will reach your target, which is nothing but the expected output. It is also a process which takes place in an iterative manner, and this is an example which you can see. I am showing the pictures of an apple and its the machine is saying that it is banana. I am correcting it. There is an error. I am correcting it, and after repeated iterations, finally the machine is able to say that it is. It's of two types, classification and regression. Whenever you try to differentiate the data into many classes, we call it as classification. Whenever you try to do a mathematical prediction, then we call it as a regression. This is an example for classification. Normally, all of us use emails. So whenever we receive an email, sometimes it is placed under not spam category, that is your original inbox, and sometimes it is placed under spam category. So how do we categorize that? The characteristic features of the correct or genuine email and the spam email are stored in the computer, and then we do the process as mentioned. So advantages, more accurate. Disadvantages, when you give too much of information, it will make a wrong decision. So always a good example, past history should be perfect. Computation time is very large, which is one of the major drawback of deep neural networks also. And if the data set is incorrect, it may bring losses. So these are some of the examples for classification, fraud or forgery detection, gait recognition, biometric authentication, medical image classification, something like a brain tumor image analysis application, sp spam detection, gene identification, food quality check. So all these are classification applications where you were forced to take a decision whether some input data X is A or B. On the other hand, regression applications are based on mathematical numbers. Your answer is going to be a number. Something like a weather prediction or a score prediction or risk assessment or any stock exchange value detection. All these fall under the category of supervised training. Thank you.